In this video, we'll take a look at section 6.2, the binomial probability distribution. So the first thing we want to do is define what a probability distribution is for a binomial. So an experiment is binomial experiment if, number one, the experiment is performed a fixed number of times. Each repetition of the experiment is called a trial. Number two, the trials are independent. This means the outcome of one trial will not affect the outcome of the other trials. Number three, for each trial, there are two mutually exclusive or disjoint outcomes, success or failure. And number four, the probability of success is the same for each trial of the experiment. So the notation used in a binomial probability distribution, N is the number of independent trials, P is the probability of success for each trial, 1 minus P is the probability of failure for each trial, and then capital X denotes the number of successes in N independent trials of the experiment. So X has to be between 0 and N. Okay, so here's an example. Which of the following probability experiments qualify as binomial? For those that are binomial, identify N, P, 1 minus P, and possible values of the random variable X. So A, an experiment in which a basketball player who historically makes 80% of his free throws is asked to shoot 3 free throws, and the number of free throws made is recorded. So this is binomial. Let's go through the criteria. Number one, are there a fixed number of free throws? Yes, there are 3. Number two, are they independent? Yes, one free throw does not affect, made or missed, does not affect the next free throw. Third, let me look back up here. For each trial, there are 2 outcomes, success or failure. That is true. Success means he makes the basket. Failure means misses. And then the probability of success is the same for each. So yes, the probability that he makes the free throw is 80%. So we'll just do part A. So A, we would have N is equal to 3 trials. Probability of success is 0.8, 1 minus P is 0.2, and then we're recording the number of free throws. Okay, the other two, please take a look at your textbook or you can look at the video solution. Next is how to compute a binomial probability. There's a formula. So the probability of obtaining X successes in N independent trials is given by the formula. Probability of X is equal to the combination of NCX times P to the power of X times 1 minus P to the power of N minus X, where P is the probability of successes. So we'll see how the formula works, and then we'll go ahead and use the calculator. So on the problem, we have, according to CTIA, 41% of all U.S. households are wireless-only households, no landline. So I'm going to write probability is equal to 0.41. In a random sample of 20 households, so N is equal to 20, what is the probability that A, exactly 5, are wireless only? So we want probability of 5, so in this case, X is equal to 5 for part A. So the probability of 5 is going to equal, let's look at the formula above, the combination NCX. So N is 20, CX, which is 5, times P, probability of success, which is 0.41, to the power of X, which is 5, times 1 minus P, 1 minus 0.41, to the power of N minus X, to the power of 20 minus 5. So the formula we can go ahead and do on the calculator. So from the last chapter, 20 choose 5, we would have 20. This is a combination, so let's hit math over to probability. Option number 3. 20, select 5. enter, that's 15,504, times 0.41 to the power of 5, times 1 minus 0.41, which is 0.59, to the power of 20 minus 5, which is 15. So I can continue with the calculator times 0.41 to the power of 5, arrow over, times 0.59 to the power of 15. Hit enter, and that tells us our probability. So our probability of 5 is equal to 0.0656. All right, so the probability of exactly 5 wireless. So that's using the formula. What I'd rather have you do is use the calculator. The calculator has a function called binomial PDF. And that will tell you at for a single probability of 5. So the binomial PDF function, be clear what's here, is in distributions. So you hit second variables, scroll down to binomial PDF. In this calculator, it's option A, and they want number of trials. So in this case, number of trials, n, is 20. The probability of success, in this case, is 0.41. The x value, what we want is exactly 5. Paste, and it will put it in the order binomial PDF, and it has n, p, x. Okay. Hit enter, and we get the same exact answer, 0.0656. So I wanted to show you how the formula worked, but use the calculator. So if you have a single probability, use the binomial PDF and type in n, probability of success, and x, the probability that you're looking for. Part B, we have fewer than 3 are wireless only. So fewer than 3, so a probability of 3, fewer than 3, less than 3, would mean the probability of 0 plus the probability of 1. So fewer than 3. So if we want fewer than 3, I'm going to show you a plus probability of 2. There's a function on our calculator that will give you the sum of 0, 1, 2, or up to what you put in, and that's called the binomial CDF. CDF means cumulative, binomial cumulative distribution. So if we put in px still, what it's going to do, I'm going to put in binomial CDF. N in this case is 20. P is 0.41, and I'm going to put in 2. What that's going to do is the probability of 0 plus each probability up until the number you put in. So the binomial CDF will give you the sum of probabilities from 0. So binomial CDF, so that's in distributions. It's right below the PDF. So it's option B. Number of trials is 20. P is equal to 0.41. And the x value is 2. Hit enter, paste. So the CDF is going to give you the sum of all 3 all at once. So that's approximately 0.0028. So the calculator will give you a single point distribution, and it will give you a cumulative distribution, just depending on what the question is asking. The next question, part C, says, find the probability that at least 3 are wireless only. So C, the probability that at least 3 would be the probability X is greater than or equal to 3. So at least 3 actually has to do with part B. We know the probability of 0, 1, 2, so to find the probability of the rest greater than or equal to 3, we can use the complements rule. That's 1 minus 0.0028. All right, last question. D, find the number of households that are wireless only. That's between 5 and 7 inclusive. So that one, you would use probability of 5 less than or equal to X less than or equal to 7. You would find the probability of 5, add probability of 6, and then add probability of 7. So it might be just as easy to find the probability of each and then add them together. All right, the mean, the next part of the lesson is how to find the mean and standard deviation of a binomial distribution or a binomial variable. So when you found it for a probability distribution in the last section, you had to type in your probabilities and you had to type in your X values. In this case, if it's binomial, there's a different calculation. So a binomial experiment with n independent trials and probability of success P has a mean and standard deviation given by, the mean is n times P, the standard deviation is the square root of n times P times 1 minus P. So there's no need to type it in the calculator. All you need is n and P and put them in the formula and you've got the mean and the standard deviation. So here's the example worked through. According to CTIA, 25% of all U.S. households are wireless-only households. In a simple random sample of 300 households, determine the mean and standard deviation of wireless-only households. So the solution, let's see. Let's go ahead and compute our formula by hand, okay? So the mean would equal n times P. So the mean is equal to n, 300, times P, which is probability of success, 0.25, which is equal to 75. So the mean of this distribution is 75. The standard deviation is the square root of n times P times 1 minus P. So our standard deviation would be the square root of n, which is 300, times 0.25, times 1 minus 0.25. Throw that in the calculator, you'll end up with 7.5. Okay. And this is wireless only households, okay? So the units of mean and standard deviation are the same as the units here. Okay, so that's how to find the mean and standard deviation. If you have a simple random sample of 300 households, 143 were wireless only. Is this unusual? Okay, so unusual is, here's our solution. Unusual means 2 standard deviations above or below the mean. So if with a mean of 75 and a standard deviation of 7.5, 2 standard deviations below the mean would be 75 minus 2 times 7.5, which is 60. 2 standard deviations above the mean, 75 plus 2 times 7.5 is 90. And that means that 143 wireless-only households would be unusual because it's more than 2 standard deviations from the mean.